Hello, everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you know that this is an online platform for civil structural engineers to interact with us and ask their doubts or queries that they may have related to any RCC steel design concept or any project that they are doing or construction and site related issues or queries. So, this is the 76th such episode that we are conducting, and let us begin by taking the queries that have been asked for this week. So, first, I'll take the queries from the Google form and email, and then we will take the queries from live audience. So, let me start. The first question that has been asked is by engineer Abdul Rahman. He is a working professional from UAE, and what he is asking, let me just copy and put the question over here. So I'll just share my screen first. Yeah, I hope the screen is visible. So he's saying in ETABS, I have modeled the staircase together with the main building. The columns are divided at every floor level and also at each staircase landing level. The columns are restrained by beams in one direction and by the landing slab in perpendicular direction. Can the staircase landing be considered as an intermediate lateral support for determining the column unsupported length? See, the general rule or general concept for any element which we can consider providing effective lateral support is that it should be able to resist 2.5% of the axial load in the member for which we are assuming lateral restraint. That means if you are saying that whether or not the staircase landing slab is providing effective support to the column, then that landing slab should be able to resist 2.5% of the axial load in that column. And this landing slab, when we are checking this should be able to take it in compression. Okay, should be able to take this axial 2.5% of axial load in compression. So this means that in elevation, suppose this was my column, just drawing a very rough diagram, and this was my staircase landing, whatever. Okay. So whatever is the axial load in this column, you take 2.5% of it, and that this landing slab should be able to resist in compression. So generally our landing slabs are sufficiently wide. They have good amount of thickness, let's say 150, 175 mm generally, and they have sufficient reinforcement also. So most of the times this will be able to act as an effective lateral restraint. Okay. Is my modeling approach correct? Yeah, if you have modeled everything together, no problem. And ETABS will anyway take the effective lengths as per the connectivity. So unlike STAT, ETABS is smart enough to take the connectivities as per the modeling that you have done. So yes, you can proceed in this manner. The next question asked is from engineer Mohsin Bagban. He is an independent consultant from Mumbai, and he is saying difference between auto construction sequence versus modify and deform geometry in buildings having large lateral displacements under gravity loads. In STC 18, so this was our tall buildings course. In tall buildings course, the background of auto construction sequence was explained for vertical deformation under gravity loads. Please explain auto construction sequence for lateral deformation under gravity loads. So he's saying generally we use the concept of auto construction sequence and undeformed geometry. Those principles are generally used for calculating the axial deformations in structures where the axial deformation may become important criteria to consider in design, especially in tall buildings and uh, structures where there is a large accumulation of axial loads. So over there, usually the vertical deformation of columns is to be factored in your designs, in your calculations, and over there we use the concept of auto construction sequence and the concept of modify and deform geometry. Now he's saying if your structure is having such a configuration that there are large lateral displacements under gravity loads, so there might be unsymmetries or there might be situations where you have some structure which under the effect of gravity load is having lateral deformations. So over there he is asking for the auto construction sequence. Use any basic framing model with top story this and explain what ETABS does in background to counter this lateral deflection as construction progresses. As many firms use auto construction sequence but don't have clear understanding of what to do at site to achieve similar results as model. Okay, so my knowledge about this or my study about this right now is limited in this regard. In this regard, so as of now, I am unable to answer this question because I have not done much study on this. I did study on the vertical deformations, which we had covered, but not for the lateral deformations. So as of now, my knowledge on this is limited. So I'm unable to answer as of now. If anyone in the live audience has any comments to make about this, anyone in the live audience, do they have any comments or observations on this topic? Okay, so our live audience also does not have any comments to make. So I'll go to the next question. And if I do, and when I do some study on this, we will maybe probably discuss this. Okay. All right. So moving on. Next query is from engineer Aditya Shilkar. He is an independent consultant from Goa and he is asking use of shell and membrane in slabs. I found that using shell gives lower reinforcement as compared to membrane. Is it correct approach? See what happens when you do shell and membrane is that when you do shell, so shells have in plane stiffness, membranes also have in plane stiffness, but shells have out of plane stiffness also. Let's say in the gravity direction, whereas membranes do not have any out of plane stiffness. So you may imagine a membrane to be like your tensile structure or tensile roofs that you may have seen, those white colored roofs that we put. So a membrane is like that, all right. Whereas shell is having an out of plane stiffness as well as in plane stiffness. Now, when we do an RCC slab, it is more closely related to an action or a behavior as shell as opposed to membrane. Okay, because RCC slabs do exhibit out of plane stiffness also, in plane stiffness also. Whereas, let's say a tensile roof, if it was, it will only exhibit in plane stiffness, no out of plane stiffness. So, when how the load transfers in shell, it will be in proportion to the stiffness load transfer in case of shell will be in proportion to the relative stiffness between the slabs and beams. Okay, relative stiffness between. So just like we do moment distribution between beams and columns, let's say there will be moment distribution between slab and beams also. So there will be a relative stiffness distribution between slabs and beams, and that is how the moments get transferred from shell to beams. Whereas in membrane, it will just be on the basis of, because there is no out of plane stiffness, so the gravity load or the perpendicular load to the membrane will be divided just on the basis of tributary area. Okay. So that's why it may happen that in membrane the load distribution changes, and especially you will observe this for for larger aspect ratios, because what will happen for larger aspect ratios? See, suppose I have a slab like this. This is the plan view. These are four columns. Okay, and these are four columns and four beams. Let's say now this is, I have modeled it as a shell, and then I have same geometry, model it as a membrane, and you will see right now that the aspect ratio is almost close to 1. So now what will happen, that in membrane the load distribution will be on the basis of tributary area. In shells the load distribution will be on the basis of relative stiffness, because all the spans are same, and because let's say beam sizes are almost similar for each span. What will happen, almost similar load transfer will happen in this case whether you are using shell or membrane. Understood? But if I were to change the aspect ratio, what will happen, and if I take aspect ratios which are having larger values, then what you will see, there will be considerable difference between shell and membrane results. So here what will happen now, in this case, as we know by the stiffness distribution approach, sorry, the tributary area approach, the larger loads will be transferred to here across the shorter span like this, tributary area approach. This was membrane. So here you will see large variation in this long beams as compared to your case where you have modeled it as a shell. Because in shell still the distribution is happening on the basis of relative stiffnesses. Okay. So in these cases you will see greater differences when you compare shell with uh, membrane. But if your aspect ratio is closer to 1, you won't see much of differences between shell and membrane. So if you are asking me what is the correct approach, the behavior of RCC slab is closer to that of a shell, because RCC slabs do exhibit out of plane stiffness. Now in older times, let's say 15-20 years ago or 20-25 years ago, when the STAT software first came, the plate modeling options were not quite well developed. So that lead to engineers using the membrane type of modeling, where they just used to transfer the slab load directly to beams. But then when the softwares have improved, especially the ETAB software where you have good shell modeling options available, so now it is better to model slabs as shells rather than doing it as membrane. Okay. Okay, so this was my answer to this query. Moving on, and next question is from engineer Rohit Kashyap. He's a working professional from Guwahati, and he is asking, when I design a pile cap, no, sorry, when I design a pile cap with shear wall, I do not face any problem of load transfer. But when I have to design a footing with shear wall, the footing size becomes very large. Sometimes I have to combine it with nearby columns to handle the stresses, and the footing becomes very uneconomical too. So I just want to know how to model a footing with shear wall. See, it's quite natural what's happening with you in plan view. Let's say this is your shear wall. So your shear wall, because of its large stiffness, will have large moments that it will resist about this axis, isn't it? About the y axis, it will resist very large movements. So when you are providing, and because you are in Guwahati, I'm assuming you have soils which do not have large bearing capacities, isn't it? You would get 10, 12 tons per square meter SBC is what you get in Guwahati and those regions. So when you provide a pile cap and piles, it is very easy because of the large movement you have. It is very easy to have a pile cap, because then in the form of piles you have some elements to resist the tension due to the generated movements. Okay, so providing piles below your shear walls is a good option, because you have introduced an element which can take the tension generated due to that moment in the wall. Whereas if you have footing, if you provide a footing, now because in your case your SBCs are quite low, what will happen, that you won't be able to manage the bearing pressure calculations P by A plus M by Z, sorry, P by A plus M by Z to be less than your SBC, and P by A minus M by Z to be greater than 0 for no uplift. For large movements you will not be able to manage it well, and for shear walls with large movements you won't be able to do this sizing quite well. Okay, because what will happen, either you will face the problem where SBC where the maximum positive pressure goes beyond SBC, or there will be large uplifts, so you will have to go on increasing the size, and that leads to being uneconomical. So if you have large movements in shear wall, which you will have usually, providing an element which is able to take tension is the best option. So for you, providing piles below shear walls is the best option that you have actually. Yeah, he's saying the SBCs in his region are quite low, 10 to 12 tons. Yeah, because in the entire northeast, right from Indus right till Ganges, Brahmaputra Ganges, the entire Indian subcontinent northern belt is full of alluvial soil for 30 40 meters depth. So you won't get any good bearing capacities over there. So the best option in such cases is to go for piles, and you will be able to provide piles. Friction piles do work well in your region. So my suggestion is, don't try to go for footings. Pile cap is the best option for you in your region. Okay, you don't have rocks also. Otherwise, we do rock anchoring also sometimes. So yeah, all right. Next query is from engineer Aditya Raj Mehra. He is a working professional from Delhi, and he is asking how to calculate fire tender load and temperature load. So fire tender load, is it? I'm just asking the live audience. Is it given in NBC? I assume it is given in NBC, right? Anyone in the live audience who can answer? Is the fire tender load for, let's say, your ramps or your parking areas, are those loads given in NBC? I think it is given in the NBC, so you will find that data from there. Okay, or generally you may get some reference from IRC 6. Fire tenders are not very heavy that way. You see, it just carrying water, and it's a truck after all, so it's not so heavy. So otherwise, usually what people do, around 5 to 7.5 kilonewton per meter square area load in the complete area where fire tender is expected. This is what they put, or you may just check it up in NBC. I'm sure there is some guideline given over there. Okay, And for temperature loads, you can refer to your IS 875 Part 5. There they have given isothermal maps where you can get the maximum and minimum possible temperatures. Okay, and from there, with comparing it with the ambient temperatures, you can find out the plus maximum possible temperature change, which will cause expansion, and maximum possible temperature change, which will cause contraction. So from there you can apply those temperature loads in your software. Generally, you should apply the temperature loads to exposed areas. All right. Not It's not required to apply temperature loads to each and every element. Generally, to exposed areas, you may think of applying it. All right. So this was his query. Mr. Rohit is asking a follow-up question that what to do if clients require footing. No, how does client decide? You are the one who is deciding. Client is not deciding. It's your job to decide for the client. You have to educate your client and tell them that what is the best suited structural element for the particular structure that you are designing for, right? So clients don't require footings or pile caps. Clients require their structure. All right. And because you are in seismic zone 5, naturally your lateral loads will also be substantial. So even for G plus 3, 4 building, uh, you will get substantial lateral loads. So it's okay if footings are large. I was worried that I was doing some mistake in the footing sizes. See, assuming everything, the other calculations that you have done are correct, then footings will be large as I just explained because the moments are quite substantial in your walls. Axial loads are also great, but not so high in magnitude as compared to the M that you're getting in your shear wall, isn't it? And because this thing is happening that your SBC is low, so the P by A plus M by Z is a problem, and because of that, you will have to keep on increasing the sizes. Yeah. So you can do one thing to tie these footings with some adjacent foot. I mean, this shear wall footing, you can always try to tie it up using strap beams or tie beams at footing level to the other footings. That is always a good option to distribute the overturning moments. For example, this is your shear wall and footing, and then there is some adjacent column. You can think of tying it up by tie beams in order to distribute the movement that is coming from the columns, shear walls. Okay, so providing tie beams is also a good option. Tie beams at footing bottom level. Okay, moving on. Next question is from engineer Raghu. He is a working professional from Bengaluru, and he is saying in PEB course Excel sheet for column base plate pin connection, there is no center to center distance between outer bolts. So if we enter it as 0 in Excel sheet, will it still provide correct results? Okay, I'll check and get back because I will have to check the Excel sheet. I am not able to remember it fully right now. Also regarding total number of bolts, does this refer to the number of bolts in that particular row or that? Okay, these 2 points or this first point, I'll have to go back and look in the Excel sheet. Okay. In the PEB course, you explained that providing stiffeners to a pin connection would cause it to behave like a moment connection. However, many PEB vendors do provide stiffeners with the base plate for pin connection. They state that stiffeners are provided to reduce the length of the base plate length or span, and that a fixed connection is achieved only when bolts are provided outside the flanges. Could you please clarify this aspect? See, moment connection means it will not overnight become a rigid connection. Understood? So, by moment connection, I do not mean to say that it will become a rigid connection as such. So, what you are saying, or what he is saying, or what we discussed is, let's say this is the plan view and this is a pin connection. So, ideally, I would like to have a pin connection with bolts as close as possible to this centroidal bending axis. Okay. An ideal pin would have been if I were able to provide an actual pin means an actual pin which would look something like this. Let's say this was my column in side view, and if I was able to somehow provide an actual pin like this, okay, and then I would, if I were able to provide some element like this would have been an actual pin. Because I'm not able to provide such a thing, it's not convenient enough to do such fabrications. So what is the next closest thing I can manage is something, an assembly something like this, where I'm trying to put the bolts as close as possible to the centroidal axis. So what I was saying is that ideally in this case, I would not want to have any additional stiffeners added to the column and base plate, because what will happen then, this stiffeners will start providing some level of moment resistance to this connection, because now this gets connected through welds and all those things. So at least the compression part is being resisted by these stiffener and column base plate connection, although the bolts are still near the centroid, so there is no tension taking element as such, because bolts are very close to the centroid. So tension element is not being taken, but for the moments, at least for the compression at least, there will be, these stiffeners will start providing some sort of uh, stiffness. So that's why I had said that as far as possible, we don't wish to provide any stiffeners when we are going for a pinned connection. Okay. But yeah, tension element is the bolts, and as long as tension bolts are close to the centroidal axis, there will be no tension taking elements. So providing stiffeners may not make such a large difference in the overall moment resistance, but I would like to have no stiffeners connected to my column and base plate in a pin connection. Okay. Yes. So I hope this answers your query. So to summarize, what the Kirby people are saying is not very incorrect, not incorrect, but then we would like to avoid stiffeners as much as possible in a pin connection. All right. Then next query is, when footings are designed in the RCDC software, the reinforcement obtained is less compared to SAFE software. This is because RCDC follows rigid body analysis while SAFE follows finite element analysis. Could you please clarify on this? See, RCDC will only do for your isolated footings. The normal RCDC will only do for isolated footings. Okay, where it will just do your normal manual calculation that we do. All right. So if it's an isolated footing, not subjected to any movements, not subjected to any not subjected to any movements at the top face, then I don't think the reinforcement will vary. The reinforcement we have checked is that the RCDC reinforcement, the SAFE software reinforcement, and manual calculation reinforcement give almost similar outputs for isolated footings, not subjected to any movement at the top, not subjected to any tension at top face. All right, but the same cannot be said for combined footings or footings where you may get tension at the top face. Okay. So there RCDC will not be able to do any calculations. And for normal isolated footings, what I have compared is that the reinforcement outputs will be similar for or almost the same for manual calculations as well as for RCDC as well as for safe. All right. Okay. So this was Engineer Raghu with his query. So these were all the questions on the Google form. Now we will take up the queries from the live audience. So Mr. Salman is asking how to check long-term deflection in safe software. So that's a long that's a long answer which I cannot explain manually uh, without any software help. I will not be able to explain this. If you have any specific query, you may ask, or I'll suggest you to go to YouTube and go to the Watch and Learn series. Okay, and watch the there's a long-term deflection video on YouTube uploaded by Watch and Learn series, uploaded by CSI under their Watch and Learn series. You may watch that, or even Sandeep, Mr. Sandeep Dev, you all know him. He has also put a very nice video on long-term deflection. You may watch that, and then if you have any specific query, we can discuss. Okay, yeah. Then Engineer Rishabh Thakre is asking. Many consultants have told me that there is no need to apply wind loads for structures up to 30-40 meters height in Mumbai, as we have used seismic response spectrum, as it has governing load combination. How correct is this? No, you should apply wind loads. 30-40 meters means you are looking at 10-12 story buildings. So wind load should be applied. Wind load, you apply wind load, you apply seismic. Always remember that seismic, you are not designing for the full seismic loads. We are designing for 1 upon R. So it happens that even if your height of the structure is not very tall, but still because you design the wind effects for, let's say, the full wind loads, we try to do it as elastic design. So and the seismic loads are reduced 1 upon r, so it may happen that wind loads may become governing even in high seismic zone regions. So you should apply wind loads, also check for wind loads. You should apply seismic loads, also check for seismic loads. Whichever is the more critical, do it for that. Okay, so don't make these generalized statements. Check for both, and then whichever is the critical governing, do it for that. Okay. Mr. Raghu is saying settlement of footings will not be checked in RCDC software. Correct. But settlement of footings for isolated footings will not have a large impact on the footing design, isolated footing design. Okay. Even if you go on changing the subgrade modulus for isolated footings, I'm making this statement. So even if you go on changing the subgrade modulus, it may not lead to large differences in the reinforcement for isolated footings. Yeah. Good. The next question is from uh, Mr. Salman Roj. Roof truss, what is maximum steel consumption in roof truss per square feet? I cannot answer like this. It depends on the span, the loads, whether you have the bay width, bay spacing. Okay, it will depend on the wind loads. It will depend on the clear spans, as I have already said. So it will depend on so many factors. So there cannot be any pinpoint value that I can give you. Okay. Uh, Is there pinned based connection valid for roof truss without gantry structure for reduction size of footing as per client requirement? Yeah, you could go for pin based connections, but then you check and ensure that lateral sways are within limits. So pin based column connection can be provided, you may use, but then check for lateral sway and ensure that lateral sways are within limit. Okay. All right. Then next question is from engineer Amir Sohel. In seismic zone 3, the clubhouse has expansion joint all sides and consists predominantly of a flat slab column system with no structural wall elements. R value of 3 for the seismic design. You check in IS 13920 what is given. Go to IS 13920. No, not 13920. I think IS 1893 gives you the R values. You go to IS 1893, check R value for your system. Okay. Although IS 1893 does not allow you to provide flat slabs without structural walls. All right. So if you look at IS 1893 or even 13920, it does not allow you to provide RCC flat slabs with columns without any structural walls. That system is not included in the Indian standards. You have in the ACI, ASCE, American codes, you have a system called as intermediate moment resisting frames where they have flat slab with columns without walls as a lateral load resisting system, but not your Indian code. So check carefully before using this system. Okay. Next query is from engineer Harish Acharya. He is asking what is auto sequence load combination in ETAPS. Again, unable to discuss this because it's a long topic. I cannot discuss it over here. So I'll again suggest go to YouTube, watch and learn series. And again, there is a good video on auto construction sequence uploaded over there. You watch that video to understand, or even Mr. Sandeep Dev again has uploaded a very good video on this topic on his YouTube channel Illustrosa on the same topic, so you can watch that as well. It will be very informative and you will understand. And then if you have specific doubts, we may discuss. Next query is from engineer Abdul Khaliku. He is asking, please discuss ACI chapter 17 for supplementary reinforcement. No, so how can I discuss the entire chapter? What is your specific doubt? Basically, for to avoid concrete breakout failures, the uh, option available to you in the ACI 318 chapter 17 is to give supplemental reinforcement whereby you tie the anchor bolts together by this reinforcement and avoid the concrete breakout, which is very critical in your base plate anchor bolt design. So to avoid the most critical failure, that is the breakout failure, the code provides you an option to provide supplementary reinforcement whereby you tie together the reinforcement through that you tie the anchor bolts together through this supplementary reinforcement to avoid concrete breakout. So that is the basic concept, and for the calculations you can just have a look at the ACI chapter 70. Mr. Salman is saying, is it possible to have a 15-meter long steel truss in 375 depth? No. Again, it depends on a lot of things, but prima facie, no. Then you will have to go for a different system and not a truss system. You may think of going for a space frame or something like that, but still 375 is too small a depth. Okay. Any other question? So we have taken all the queries from the live audience and all the queries that were asked in the Google form. Mr. Raghu is asking, in safe it is showing top reinforcement, but RCDC it is giving minimum reinforcement. Why is it so? Because in safe sometimes you may see some tension steel requirement at the top face in this region. So if you observe the requirements, sometimes in this region, because of, let's say, the where you have large overhangs, there may be this bending that safe observes in this direction because of the less stiffness and large overhangs, and this may lead to some reinforcements that the safe shows at the top also. Okay, so that happens, yeah. And of course RCDC will not give you that reinforcement. Mr. Rishabh is saying how to trust depth for preliminary calculation. No, it depends on, first of all, you need to decide your slope. Okay. If you are having a truss, then you need to decide the slope. What is the slope generally you want to provide? Most usually for trusses, we may go for 1/5 to 1/6, okay, of the span. I mean, the slope, we try to go for 1/5 to 1/6. That means, let's say if it is 15 meters, half of it is 7.5 meters. That means around 1.5 meters, and 7.5 by 6 is, let's say, 1.2. So around 1.2 to 1.5 is what is the riser I would like to provide. Then depending on the secondary members like purlins, etc., and the sheeting which it will support, sorry, depending on the sheeting, we try to have a purlin spacing. Usually we try to give it around 1.2 to 1.5 meters or 1.4 meters. So that way, first we will decide the space, the positions of purlins. From there, you may think of, let's say, providing some vertical elements, and then you may come up with your diagonal members like this. So in this manner, we usually decide the configuration. Yes, Mr. Abdul Galiko is saying, please discuss a little about the composite structure course. We have sent detailed message for the course along with the course brochure, and in the WhatsApp messages also that we have sent on all our groups. We have uh, put the course contents. So whatever we are going to discuss is there in the course brochure and also on our website. So I request you to kindly go to the website or go through the course brochure, and then if you have any specific query regarding that, we may answer or we may discuss over here. So if you have any specific point to discuss, we may discuss that. But the general course contents and all those things are already there on the website. So you may have a look. Then Engineer Salman is asking, SHS to SHS beam column connection design. I check in Idea Statica. We get moment 10 kilonewton meter and shear. If I apply 6 full fillet weld, is it possible? You may try to go for a this thing. CJP welding is better rather than fillet welding. Uh, CJP is not the party, okay? CJP is the complete joint penetration weld. Groove. So where we cut a groove like this, and this is the full welding we do like this. So this is a complete CJP welding. All right. So when you are trying to connect SHS to SHS, it is better to go for a CJP weld like this. And then depending on your SHS size and the applied moment, you may check for the stiffness that this connection is offering. So stiffness check should be made. It may happen that it is able to take the moment, it is able to take the applied moments, but then the stiffness of this connection should be checked, because if the stiffness being offered in this, I mean, if the stiffness that this connection is offering is not like a rigid connection, then suitable adjustments should be made in your analysis model. Okay. Otherwise, instead of fillet weld, I will suggest you to go for a CJP welding. So you may not provide end plates. You may provide a CJP weld, but check the stiffness of this connection, and then accordingly make the necessary adjustments in your model stiffness. All right. Okay. Anything else? Any other query? So we have no more queries now. Throughout the week, you can continue to put your queries in the Google form. As you all know, the link for Google form remains the same. And throughout the week, you can keep putting. 50-meter long span RCC structure can be designed without PT beam. I think even with PT beams, it is difficult to design a 50-meter long span structure. Then you will have to change your system. It cannot be a single beam. You have to come up with some different structural system. Okay. So this is the link for Google form. Throughout the week, you can keep putting your queries. And once every week when we meet, we take up your questions. And if you want to connect with us directly on WhatsApp, this is the link to connect with us on WhatsApp. Let me just share that link. Yeah, this is the link if you want to connect with us on WhatsApp. So I think this is all for this session then. Thank you very much for joining, and have a good week ahead. We will see you next week now with another episode of Ask AuxEn Anything. Till that time, have a good time. Bye bye. Thank you very much.